keeping that panel open and checking the transformation bone constraint, here I want to remember which setup that I've made for the minimum and maximum positions for the z-axis of the target bone on local space. I'll use the max value as an example first because it's easier to understand. So it's a positive value, 0.35 meters. So this is for this bone, the target bone. So if I reset here to rest position, it's 0 meters. Then if I paste that value here, that positive value here, you see, this is the maximum height. It doesn't matter in which other transformations there are here, provide this is 0.35 meters. So this is the upper threshold in which the owner bone of the bone constraint will suffer some other transformation that for this case is also a location transformation but on its z-axis, but we'll enter on that detail later. As I pose this bone up until the threshold of 0.35 meters, this is the upper limit in which the owner bone will suffer additional transformation on that direction. As I pose the bone upwards, the owner bone starts to gain distance from it because it's being transformed through the transformation bone constraint, besides the copy location of course. But as I reach this threshold and keep moving up, you see that it stopped gain distance, and this is because that threshold maximum value was limited. So there's a scope of transformation from a maximum to a minimum values, or from a minimum to a maximum value, whatever. That difference, range or scope of transformations is the data that will be then transferred to other scope of transformation. So this is the range in which, as I pose this bone, I've decided that will be affecting that additional transformation. I didn't mention here yet, the minimum is negative 0.2 meters. That would be somewhere like this, okay? So this is arbitrary, this depends on the character design. And in this case, I've decided that the eyelash deform bone will stop going upwards even if I pose the eyelid bone higher, so that the eyelash wouldn't get even more deformation, for example something like that. So if it kept moving up, the eyelash would end up being something like that, which is horrible. If in the case of the map from data I'm actually more interested in developing which would be the maximum and minimum thresholds in which the posable bone will have additional effect for the owner bone through the transformation bone constraint. So this is more an analytical stuff, the map from data. In the case of the map to data, this is actually the deformation output that I want for the eyelash mesh in this case. The output transformation for the eyelash deform bone. This on the owner of the bone constraint. So it is also on local space because I'm also using z-axis for this bone. Here in the map 2 subpanel it tells z source axis, but this is actually the owner bone's z-axis, and I'm taking this z-axis from here. So this is the actual z-axis from the target bone. So I'm commanding that this data from z-axis of the target bone affects, so this range will affect this range. The minimum here is a smaller number than the maximum, and this is matching with the fact that here the minimum also it's a lesser number than the maximum. Otherwise, let's make an inversion here for learning purpose. Let's take here a -1 and let's put here a +1. So let's see what happens as I pose. You see I've got an inversion. Augment the scope of the map 2. So I'm making the minimum a smaller number and the maximum a larger number. And so now you see I have plenty of deformation, but because the map from the scope is still that small, so augment just a bit here, the maximum value. So now if I go beyond, it still is creating transforms. Let's even get bigger here. Let's try. Yeah, you see there's some adaptation, because if the range increases, let's say the deformations would be smoother in this range to range matching. So there are many ways to organize this and to set up this, but usually the map from is better for giving those parameters that we want, like in a more established way. We can solve this first and then we deal with this. And sometimes with some back and forth, but usually this is where we want to spend most of our customizing time for the rig. The transform panel for the deformed bone, in this case it's even easier because we can spot at the same time the transformation bone constraint on the honor bone along with its own transform panel here, which was not the case for this. We needed to be switching, right? The problem is that I cannot manipulate those data very well here because this bone is constrained exactly. So what I can do instead, so let's go on rest position, is to pick the bone and then on its bone constraint make the change, and we'll see that in real time. And so this is the minimum value. I think that for the rest pose this is good, and of course if we make also maximum value changes here, it will also produce some change because I'm changing the scope, right? The range is changing, it's simultaneously. But I can compensate, then I can pose, then I can edit in many ways. So we do that until we are more or less satisfied with the result. Of course this has relation, some degree of relation to the bones that are to the other side, so we need to make these adjustments. Like, we must always be checking. It's a bit tricky, but it's kind of a funny method to work with. And if we want to adjust certain things, for example, let's pick this other bone because it's better for this. We can also, through this unique scope of transforms, of course for that bone here, because now the target bone for this is this one, and the target bone for this one is that one, and this one is this one. So if I want to pick that one, I can use this same map from data to affect, for example, the x-axis of that deformed bone. Let's say as this bone goes up, I can make this bone augments its maximum value to the x-axis, I guess. Oh, of course I need to adapt here from the z here. Okay, and apparently I have to make some adjustments here as well. No, something. Oh, because that was the negative z-axis, of course. So the maximum needs to be negative. Okay, so I can do that. Of course, then I need to make some compensation here. And so let's see. You see, I can have multiple scopes, but I try to avoid using multiple things. If I can solve everything with just a single one-to-one range, otherwise it will get more and more complicated, right? And it's already a bit complicated, but it's an interesting method. In the case of using the symmetrize operator for the bones, right, if we want to have them automated to the other side with all their relations on edit mode and with all their functioning bone constraints on pose mode, we need to have first develop an entire side with all that stuff. Okay, we try to make everything correct for one side, and then only then should we use the symmetrize operation for all the bones of a rig, right? This re-symmetrization got an issue with the vertex group that wasn't properly assigned. It wasn't symmetrized along the process, but then it is very simple to fix. Because I have a mirror modifier on the character model, I just select that bone which has no vertex group, or I deleted the vertex group if it had one, and just click anywhere. There you go, it gets automatically a brand new, fresh, symmetrized vertex group.